Good afternoon and welcome back to my messy workbench once again, where I've got something that will hopefully be a little more interesting than a light bulb. It's a computer power supply, as may be obvious to some of you. It's a Dell PS-5161-7DS and it's out of a little small form factor Dell computer, and it doesn't work. So the problem with this thing is, you can plug the computer in and the standby LED comes on and it all seems fine, but when you press the power button, nothing actually happens, and it just flashes an orange error code for power subsystem fault, which doesn't really mean much. But basically, I've tried the motherboard, everything with a different PSU, and it all works fine, so obviously this thing here is not working properly. Not sure what exactly is the problem, but I guess we'll hopefully find out. And computer PSUs are generally not worth repairing unless you're just replacing capacitors. If it's a decent overall design and it's got bad capacitors in it, it's worth replacing those because they're cheap and easy to do, and if it's a good design it should last a long time. But if anything else is significantly wrong with it, it's generally not really worth it unless it's a really expensive one and you've got a schematic, which you generally can't find, unfortunately, or if you've got a working unit to compare it to, hopefully, which is kind of the only way you generally can do anything. So yeah, normally I wouldn't actually bother repairing something like this unless it's a really easy fault. But of course, because it's a strange shape and it's the only one that would fit in the case, I kind of have to, really. I mean, the prices for replacement ones are insane and pretty much only available on eBay, and due to the weight, shipping from America, which is pretty much the only place you'd get one, is not really worth it, so there's no point in doing that. So it's kind of a thing, well, I'll have a look at it, and if I can fix it, then great. If not, well, I'll just sell the entire system for spare parts, basically, the computer, the whole thing. It's just not worth it otherwise. So yeah, but we'll have a quick look at this and see what happens. Well, first things first, let's plug it in and turn it on, and well, let's just see what happens. So, got a power cord here, obviously, and I'll just plug it in, and hopefully it doesn't go bang. Well, it shouldn't do because it didn't go bang before. There we go. Okay, it didn't go bang. That's a good start. Now, let's take a multimeter and stick it on voltage test, and make sure we don't have it set to. Make sure we don't have the probes plugged into the amp range, because that would create a dead short across anything we try to measure. So let's go for the 20 volt range, and hopefully you can see that. So first of all, let's see if we got 5 volt standby voltage. So that's the purple wire here. Let me see if I can show you that. The purple wire just over here, that should be 5 volt standby. So that will let's measure between a black wire, which is ground, or we could measure from the actual case, but let's just go from the wiring, and purple. So okay, we do actually have the 5 volt standby rail up, so that's a good start, which is interesting that the thing doesn't turn on if it common problem could be that the 5 volt standby rail is dead, which would mean the circuitry for telling the power supply to come up would not be getting power and wouldn't be functional. But if we've got 5 volt standby, it might be something to do with the controller chip or the secondary side input circuitry that controls the PSU to start up. But anyway, let's keep going. So we should have also the green wire, which is the PS on pin. And I should point out as well that this Dell PSU has a standard ATX pinout on the main connector and everything like that, but some of the older ones, and I'm not sure about the new ones, but some of the older ones don't. Some of them, the wiring on this is completely switched around. It follows no standard whatsoever. It's just something Dell made up. So fortunately this one is standard, but some of them are not, and you have to watch out for that. Yeah, just a little hint there. So green wire is power supply on, and that one will output a 5 volt signal or so, and the motherboard actually pulls that down to ground to tell the power supply to come up. So if we measure that, We also have 5 volts on that, so that's good. So yeah, we can try forcing that manually to ground with a piece of wire, which is basically the same thing that the motherboard does. So I'll just get a little offcut of component lead and stuff it in here. So we just short that to ground, and power supply is spinning. I mean, the fan is spinning. Okay, that's interesting. Let's see what's going on here. 3.3 volt is up. Negative 12 volt is up. We got 5 volt is up, and 12 volt is up. A little bit low, but that just might be because there's no load. Well, that's typical, isn't it? The thing was not working before, and now it's working. Great. Well, now I look a bit silly, don't I? Although the 12 volt... Hang on. Ooh. Oh no. 12 volt just jumped all over the place and then went off. Maybe this stupid thing isn't tight enough. Let's have a look. Let's try that again. Let's get a tighter wire. See something a bit more solid. What we got in here? That looks a bit better. Fascinating. I'm guessing there's a loose connection or a slightly dodgy component there, but let's try that again. Now it won't come on at all. Okay. So there is still a fault there. Some sort of intermittent connection, possibly. That's interesting. And the 12 volt was jumping around. Of course, I wasn't able to measure anything. Oh, now it's coming. No, now it's off again. Fascinating. Well. Now it comes up again. Let's see. Now it's stable. I wonder if I just had a loose connection on the PS on pin. That's a bit weird. Kind of half wondering if it'll just go bang randomly now, but that's annoying. It would do that, wouldn't it? So there might be a fault and there might not be a fault. Well, there's definitely a fault somewhere because it wasn't working before, but maybe it's just bad solder joints somewhere. Well, let's open it up and have a quick look and see if we can see anything that looks a bit dodgy. Nothing really else to do, I guess. If it's working now. Alright then, let's proceed. Let's open the thing up and see if we can find anything interesting. Although, to be honest, I don't really have much hope for it being anything obvious. Now, this one has a little clip thing on the side, which allows it to be toollessly connected to the case. So you just got to take that off. And now let me see if I can remember how to open this thing. Okay, so there's some screws on the side here. There's 2 there and 2 here, and I think the one on the back doesn't need to be removed because that's just holds the circuit board to the case. So I think all we have to do is just take these 4 out to start with. Maybe 5, there's one over here as well. Let's see, maybe it was just these 4. Let's just try these 4 first. Okay, does that do anything? Yep, there we go. Okay, so that's rightio, so it's not a particularly interesting design. It's fairly standard. There's your input there, the 2 filter capacitors, you got the primary heatsink with the switching transistor on it, the transformer's buried under there, that'll be the 5V standby transformer over here. You've got the fan control and regulator board, I think. A regulator board, I mean the power supply control board for the monitoring and all that. You've got the output rectifiers, the output inductors, capacitors, and there's I think that big coil down there is a PFC coil. So yeah, but apart from that, pretty standard thing. But I honestly don't know. Pretty solder joints look pretty good on that board there. Everything else looks fairly good. I seriously can't see anything that's incredibly obvious, so it's kind of hard to say. Actually, hang on a second. Let's have a look there. The joints aren't perfect. There is a little bit of cracking around some of them, but especially on the control chip, but they're not really that bad. They don't seem to be too bad that they would cause a problem that big, so who knows, maybe they are. Well, let's reflow them a bit and see if that does anything. Okay, so I'll just reflow some of these joints that look a bit funny. And that's pretty easy to do. You just take your clean soldering iron and put it onto the joints that look a bit funny and add some fresh solder. So just like that. Very simple. Heat the original joint, add some fresh solder, add some fresh flux, let everything melt again. Pretty simple. But yeah, that could be it. May also not be it. We don't know. I'm swapping from each side of the chip package on alternate leads just to not get too much heat build up on one side at once. That's a good way to overheat things and wreck them. let's just do these ones as well. So yeah, if you can solder, you can easily reflow joints. It's pretty simple. Right. Now, that's what are the ones on that connector there? Yeah, there's a couple over here that look a bit funny as well. Of course, the other thing here is to avoid the surface mount components. There's quite a few of them on this one actually, so. That one didn't smell so good. Smelled a bit funny. Smelled like... I wonder if there's a bad capacitor on this thing. It kind of smelled a bit like one when I heated it up, which is a telltale sign. I may have to... Well, let's get the whole thing out of the case, and I just realised I missed another pair. This one's here. But yes, possibly there might be a bad capacitor somewhere on that board. We'll just have to pull the whole thing out and have a look. Right, so now I've got the thing pulled kind of out of the case. I can't get it completely out because the mains input socket and switch and the wires for this PFC coil and stuff are all connected in the front there, and disconnecting that would be a lot more annoying than just having it like this. So I'm just going to work on it like that. And the row of contacts down here, you probably can't see that, but I'll stick in a photo and all that. These row of contacts here that connect to that separate board that had the supervisor chip on it. A few of those do look kind of cracked around the pins there, and they do look a bit dodgy, just like a few of the ones on the board itself did look a bit dodgy. So quite possibly that's the problem, just some bad solder joints. Because I mean that would make sense. This thing is the that little board there is for the monitoring IC and control IC, which will affect how the PSU starts up. Well, it controls if the PSU starts up or not when it gets that low input on the green wire from the motherboard. So yeah, if there's a bad connection there or something, that could explain why it stopped working and now worked again after I took it out of the case. Just things getting moved around can, you know, cause things to happen. So but yeah, I'll desolder this board and have a look, because I did smell something that smelled like a bad capacitor when I was heating up a couple of those joints. So the easiest way to do that is with a desoldering gun. So I'll plug that in and we'll just take that off, check it out and resolder it back in, and if there's been any issue with the solder joints, they'll be completely redone. So that should fix any problem there if that was the problem, and that makes sense. It makes sense. That could well be the issue. Quite a logical thing. But yeah, anything beyond that, I don't really think I'll bother. It's just too much time unless anything's obvious. But if free flowing all those joints on that control board and on the connector down the bottom here doesn't fix it, then I'll probably just give up because it's not really worth it. The system this powers is kind of old and not that great anyway, and I was only using it because it's a nice small case and it fits in the workbench nicely, and it runs quite quiet, and it's just like a useful system to have. But if it's too much effort to put into it to get it working again, then not really much point. I can just get something, build something else, and get like an off-the-shelf small case. There are ones that are small, not as small as that one, but they are pretty small and probably better cooling anyway and all that. So yeah, we'll just see how that goes. But this thing should be hot now, so let's take these out. Oh yeah, noise warning, this thing's quite loud. Actually, that's not hot enough as yet, is it? I better turn that up a little bit too, just in case. I don't know if this is a lead-free board. I don't think it is, but because the solder is very shiny on this, you can generally tell the lead-free solder is not as shiny as the leaded stuff, which obviously melts at a higher temperature, and you need to have the tool set to a higher temperature. So let's give that a try. Still nothing. Just see what my thing's doing over here. Still recording, that's good. Yeah, hang on. That's a bit better, isn't it? Let's have the microphone actually in front of my mouth. That might help a lot. That would probably help a lot. And I should start talking a bit more loud. Yeah, there we go. That's better. Okay, so let's try that again. Okay, so let's give that another try. This thing should be hot enough now. Yep, seems good. These things are pretty great. Very fast desoldering indeed. Alright. Stick that over there. I really need to get a stand for that thing, but I don't have one, so I'll just put it over there on the side and hopefully it doesn't melt anything. Okay, so oh yeah, that's right, this thing's got a nice big splodge of glue along there, so I suppose I'll have to cut that. Okay, so a little bit of mucking around and I managed to cut this glue, and I had to take off a couple of cable ties and all that, so now I've got the board kind of free. So if I just wiggle it out a bit, it comes right out there, and we can see something awful. Well, something not that great anyway. If you can see this up there, this horrible glue, this horrible brown glue seems to have been spewed all over this thing. And it's quite funny because nowhere else in the power supply have they actually used that stuff. They've used white glue that's actually good, but for this part, for the controller there, they've put this horrible brown stuff on there, and that glue is notorious for causing corrosion to wires, to leads, to components. It goes weird over time. You can see how this lot over there is a lot more brown than that lot there, I think. Yeah, it goes conductive as well. It goes corrosive. It's really bad. It's something that that seems to be in just about every electronic device. It's just not everything. Some of the good manufacturers don't use it, but a lot of them do use it, and it's terrible. It's just garbage. It wrecks everything. So that can't stay there. And it also may be part of the problem as well. It may be causing some sort of conductive path and upsetting their circuit operation. So fortunately it's not in the primary section where the mains comes in, because when this type of glue is used in the main section and just sometimes all over the primary filter capacitors, or maybe even the switching transistor or other parts, yeah, it goes conductive over time, and with a high voltage like 300 volts DC from the rectified mains, 360, maybe even up to 400 just about, yeah, the leakage current through that is actually quite high, and the thing starts to break down and become conductive, and eventually power of high voltage ends up going to places where it's not supposed to go, and things end up going bang and stuff. So on the low voltage side, you're not really going to get explosions or dead shorts, but it can cause wonky operation, which may be the part of the problem. So yeah, could be that actually. Bad solder joints and horrible conductive glue. So I'll remove that, and I might remove all those capacitors as well, because they may well be bad. I might as well let you in on a little secret. I actually replaced most of the output capacitors and some of the primary startup capacitors and stuff in this thing a while ago, and initially it wouldn't, the voltages were all out over the place, and the thing wouldn't power on reliably at all. And after replacing all those capacitors, everything seemed to work fine, but yeah, a while later we have these issues, but I'm thinking that could be to do with this. Definitely, well, these capacitors won't affect how the thing runs, but they may affect the voltage feedback, and might be why the 12 volt rail was a bit low before. But yeah, the this chip here will do control. It's a well-trend 7515. So there are different ways to remove this glue. Sometimes it becomes brittle enough that you can just pull it off. Like, take a pair of pliers or something, you can just sort of grab bits of it and just rip it off, and just sort of disintegrates. And you pull it off from around everywhere that it shouldn't be. But if it hasn't gone brittle, it sometimes can be a bit more difficult. So often, like this bit here, I can grab that, but it doesn't do much. So heating it up is often a good help. So that's where you get your hot air station. So we get a bit of heat. You don't need much. I've just got this on lowest, which is about 150 degrees, but that should do it. Heat the stuff up, and it becomes soft, and you can start sort of taking it off a lot better. This stuff really is terrible. It really is. It's complete garbage. Shouldn't be used in anything, and yet they still use it. So yeah, I'm not going to bother showing a video of me doing all that, because that's quite boring. So I'll skip in a second to after I've done that, and we'll see how that goes. Alright then, so after a bit of work to remove the glue and the affected components, which are over here now, yeah, it can be a bit of fun scraping everything off. So I had to desolder these parts and scrape the stuff off, but now I have a look, it's nice and clean. there's no garbage on there anymore. Everything's pretty good. Had to take off quite a few things. As it turns out, the this little right-angled header thing, that's gone. All the capacitors were covered in that garbage. They're all gone. Well, they're probably rubbish anyway. They're all crap brands and they were pretty old, so yeah, probably not worth keeping them in any case. And a couple of well, a transistor here and a TL431 shunt regulator. They probably still work fine, but the glue has been, I mean, I think there's a photo somewhere, but I mean, yeah, the glue has gone all up completely all over the legs, and it's just started to corrode everything, and basically it'll just eat its way up. The corrosion will just eat its way up into the through the leg up into the component body and just destroy everything. So basically, yeah, this glue, just sort of light brown glue, often referred to as the evil brown glue or evil tan glue. It literally destroys everything it touches. If you leave it on there long enough, it's just poison for electronics. It's like the electronics equivalent of flesh-eating disease or something. Basically, it just wrecks everything. So if you have something you care about and you're repairing it, and you find this stuff on anything, just before it starts corroding things, pull it off. Just get rid of it. Take the whole lot out. There's no way that leaving it in is ever going to be a good thing. It's just terrible. It just destroys everything. So get rid of it. I mean, some of the stuff like this white glue, it's fine. It doesn't do anything. It just works perfectly fine as glue. But that brown stuff, it's evil. It really is. It's completely evil. It just destroys everything. And yeah. I don't know why they've used good glue everywhere else and crap glue on this part. It seems a bit odd. I don't know why they didn't use the good white stuff all over the whole thing, but yeah, pretty strange. You just wonder, did they do that on purpose because they knew it would do that? I don't know. Anyway, but going by the fault of this thing just randomly not turning on and being a bit weird, and this is the board that will do the control of that, and would definitely a fault on this would affect the thing turning on. So I'm guessing possibly one of these parts is starting to fail. The capacitors are probably all dead already anyway from heat and just old age, and there were some cracked solder joints. So I would say that all those things together, quite possibly that was the problem. So I'll need to get some new capacitors for this thing. Need to get a bit of a right angle header thing. I'll have to replace this TL431 and this transistor. This transistor doesn't seem to be anything special. It's a 2SA1023, and it just needs to do the fan control basically. Just obviously switches 12 volts for the fan control because this thing's got a smart fan controller in it that obviously keeps the fan nice and quiet if the thing's running cool. Yeah, stuffed inside this little tiny box. I don't think this thing will ever run cool, but anyway, that transistor will have to be replaced obviously because again, it's just the leads have all started to corrode all over it, and yeah, it'll just get worse from there. So just have to replace the whole thing. Nothing else you can do if this stuff starts to attack components. You just have to replace them. Basically, there's no other option. It's just complete garbage, really, really bad. And yeah. Anyway, but that's enough for me for today. I've got to take a break now. So see you next time.